Greetings to you all. I am Dr. Anveshni Dumala, working as an assistant professor in the Department of Information Technology in Vignan's Nirula Institute of Technology and Science for Women. So today we are going to discuss few topics in Unit 4. So in this Unit 4 we are going to cover the conventional TCP IP protocols. So under that we are going to see the indirect TCP, snooping TCP, mobile TCP, right? Retransmission and fast recovery, selective retransmission. Next we are going to see the timer freeze out TCP, and finally we are going to see the transaction oriented TCP. Next we are going to see the database issues. So what is meant by database hoarding, database caching techniques. We are going to see the transaction models we have. In that we are going to see the ACID properties. Next we are going to discuss the client server computing and adaptation. So after that we are going to see the query processing, query data recovery process, and finally we are going to address the quality of service issues, right? So now let's discuss them one by one. So in this fourth unit, that is a mobile TCP, we are going to focus more on the transport layer. That is also more on the TCP protocol, that is transmission control protocol. Fine. So what is in the third unit, we have already seen that internet protocol is specifically designed for the fixed networks and it doesn't support the mobility. So that is why we have discussed some extensions that are made to this IP and we called it as a mobile IP, right? In the same way, see, we have different layers in the reference model, right? So TCP IP model has different layers. So all the layers should support this mobility of these mobile devices. That is all about the mobile computing, right? So in third unit, we have discussed enough regarding the mobility support by the internet protocol. In the same way, we are going to see how this TCP is going to support the mobility of the devices, right? So the main motivation is like the transport layer is responsible for fixed end-to-end systems. It is also like it is also responsible for error recovery. It is responsible for flow control. It is responsible for the congestion control, and it should ensure the complete data transfer in the TCP, and also it should be able to do an efficient retransmissions, right? So all these things motivated this TCP, motivated this transport layer to address all these issues. At the same time, it should also support the mobility of the devices or the users, right? So first of all, the things that we are going to use throughout this fourth unit are congestion. So in the last classes, we have seen that we have different terminologies. We have discussed regarding collision. We have discussed regarding contention. Also, we have discussed regarding the congestion, right? So don't get confused. All the different terminologies have their own application, right? In different fields we use these different terminologies. So in this fourth unit we are going to focus more on the congestion, right? So this TCP is responsible for this congestion control. Before going into that, how this congestion is controlled, now let us see what is congestion. So every network has its own capacity to traverse the data, right? So if the sender is sending more data beyond the network's capacity, then what happens, right? So if we are using the efficiency or the capacity of the link, then it is fine, we get the throughput, right? But if we are sending more data beyond the capacity of the network cannot process them. Moreover, see, we have devices like sender and receiver. So these sender and receiver are connected by using the interconnecting devices like routers, right? So router has a special quality like storing and forwarding the packets to the other devices that are connected in the other networks, right? So here what we are doing, we are sending packets beyond the network's capacity. Here router cannot handle them. So what it does, it just drops the packets. So here at the initial stage of transmission, we achieve the gradual increase in the throughput. But suddenly we can observe that there is a sudden fall in the throughput, that is because of the congestion in the network. That is, router is not able to process all the packets that are coming with the high speed into the network. So it just handles that situation by dropping the packets. So we are calling that serious condition in the network as congestion. So congestion is a condition in the network where there is a sudden fall in the throughput because the source is sending more data onto the network beyond its capacity. So here the packet loss in fixed networks, typically it is due to the temporary overload situations. So routers have to discard packets as soon as the buffers are full. So TCP recognizes congestion only indirect via missing acknowledgements, retransmissions, unwise. So they would only contribute to the congestion and make it even worse. See, we have already seen that this TCP is specially designed for only the fixed networks, where the devices have no ability or no support for mobility, moving from one location to the other location. So can such TCP can be used in these wireless networks? Obviously not, right? It requires some modifications to it, right? See, TCP is designed for the wired network. So in the wired network, if any packet is lost, so the TCP is designed in such a way that it will treat or it will think the reason behind this packet loss is only because of the condition. There are no network issues, there is no transmission error, there is no fabrication of this data during the transmission. So the only reason behind this packet loss is only because of the congestion. So what it does, it just minimizes the congestion window and gets the situation into a normal state. That is how it solves the problem in the network. But in the case of wireless network, there are a lot of factors that are impacting this packets. That means there are a lot of reasons or different factors that are behind this packet loss. So this first TCP has to find out what is the reason behind this packet loss, and then it has to start the solution. But if we use the same wired TCP in this wireless network, then what happens? Whatever the reason is there behind the packet loss, it just think that it is only because of congestion, and it just makes the congestion window as 0. So without knowing the reason behind the packet loss, if the TCP is just making the congestion window 0, means that what does that mean? We are just not utilizing the full capacity of the network, right? So efficiency is not achieved there. So first of all, we have to know the reason behind the packet loss. So if the packet is lost, it is not only because of the congestion in case of wireless networks. So it might be due to the transmission errors, it might be due to the climatic conditions, it might be due to the network issues. So a lot of reasons are there. It might be a temporary there is a slow transmission in the network. So there might be a little delay in getting the acknowledgement. If acknowledgement is delayed, it doesn't mean that congestion is there in the network, right? So we are going to see them in detail with the examples. It is quite interesting. And before that, we just remember that this TCP, this default TCP or the existing TCP that is meant for this wired network will solve the congestion problem or the packet loss problem only by using this slow start algorithm. That means it just makes the congestion window equal to 0, and slowly it will start increasing the window and finds the transmission is happening successfully or not in the network, right? So that is the congestion, and this congestion is handled by this TCP. So TCP, congestion control. So now how this TCP uses this slow start algorithm, we'll see that. So here the sender calculates a congestion window for a receiver. See, congestion window is maintained both at the sender and the receiver, right? Both should be in the sync. Otherwise, packets are lost, right? So both should have a synchronization between, right? So the sender calculates a congestion window for a receiver. According to the processing capacity and the buffer size of the receiver, sender has to plan its pace of transmitting the packets into the network, right? So start with a congestion window size equal to 1 segment. It just initially starts setting the congestion window equal to 1. That means at a time it can set only 1 segment, right? So here we are using again different terminology regarding this packet. So in the previous unit, in third unit, we studied about the internet protocol, that is network layer. So we have used like packet. So at different layers we use different terminologies, right? At physical layer we are calling it bits. In data link layer we are calling it frame. In network layer we are calling it a packet. So in TCP, that is in transport layer, we are calling it a segment. So whatever the word that we are using throughout this mobile computing, so just remember we are mentioning the data, right? So since it is a transport layer, so we are calling it a segment, right? So to start with, this TCP will start with a congestion window size equal to 1 segment. So there is exponential increase of this congestion window up to the congestion threshold, then it linearly increases. So you have to observe one thing. At initial point, this congestion window is set to 1. Okay, so 1 segment is sent. If the corresponding acknowledgement is received, again this congestion window is increased exponentially. It is made 2 segments. Again 2 segments are sent. So if for 2 segments, if we get the acknowledgement successfully in time, then what we are doing, we are again increasing this congestion window exponential, that is we are making it 4. So at a time we are sending 4 segments together. If we get the acknowledgement within the timeout, okay, this process continues until there is no congestion observed in the network. So once the maximum threshold is met, then we are not increasing the congestion window exponentially, but then we are increasing it linearly, right? So there is a linear increase and it continues until a timeout at the sender occurs due to a missing acknowledgement, or until the sender detects a gap in transmitted data because of continuous acknowledgements for the same packet. If you are getting continuous acknowledgement for the same packets, that is if we are getting duplicate acknowledgements, what does that mean? That means some acknowledgement is missing. So missing acknowledgement causes the reduction of the congestion threshold to 1/2 of the current congestion window. So we have slow start, that is there in the name itself, right? So we are slowly starting by increasing the window size exponentially once the threshold is reached. So linear increase is there. So if we observe any late, or if there is any missing of the acknowledgement, or if there is any duplicate acknowledgements, then what we are doing, we are just minimizing or reducing the threshold to 1/2 of the current congestion window that we are maintaining, right? So congestion window starts again with the 1 segment. So we are again coming to the initial point and continuing this process. So according to the situation in the network dynamically, we are adjusting the window size. That is how we are able to handle this congestion. At the same time, we are able to use the link capacity to its fullest capacity. Got it? So in the diagram, you can observe like on y-axis we have taken the congestion window. Congestion window in the sense how many segments that we are sending at a time, right? So that is decided by the receiver's congestion window. So how many packets it is able to process. So how many packets it is able to store in its buffer. So depending upon that, this sender and the receiver will come to a common point, like how speed this transmission should happen and how many segments are to be sent at a time, right? So depending upon that deal, the sender is going to decide its congestion window, right? So on x-axis we have taken time. The time is measured in rounded trips. Like we are sending the segment, and the segment corresponding acknowledgement should also come, right? So the time that is required for this packet to go to the receiver and also get back the acknowledgement. So time required to go and come. So rounded trip time, right? So here you can observe at initial stage we have the condition window 0, and window size is increased exponentially once the threshold is set, once the threshold is met. So here we have considered like slow start threshold is set to 8, right? So by default the threshold is set to 8. So after reaching this threshold, if we observe that packets are going well, so packets are transmitted successfully and we are getting the acknowledgements also successfully in time, that is before the time is out. So the condition is good in the network. So what we are doing here, we are increasing the congestion window linearly. So after we are reaching the congestion window to the maximum and we observe there is a duplicate acknowledgement receiving, or there is a slight delay in receiving these acknowledgement, then what we are doing, we are just making the congestion window equal to again 0 and slowly starting the process. So when we are doing this congestion window equal to 0, when the timer is out. See, before any transmission is initialized, at the same time parallelly what we are doing, we are also setting the timers, right? So if the timer is out, then again the process will again start from the starting point, and again slowly increasing the congestion window, going to its maximum capacity. Once the timer is out, again coming to 0. So this process continues until the sender and the receiver have data to exchange, right? So next one is TCP fast retransmit or fast recovery. So if a sender receives several acknowledgements for the same packet, this is due to a gap in the received packets at the receiver or because of the missing acknowledgements. So the sender can now retransmit the missing packets before the timer is expired. So this behavior, we are calling it a fast retransmit. It is very important. So please remember that this is a fast retransmit. Before the timer is out, if we observe there is a gap in the acknowledgements, or if there is a duplicate acknowledgements, so before the timer is out, we are just retransmitting the packet, so that we are stopping this TCP from making the congestion window equal to 0. See, it is very interesting, right? So this is how we are going to handle the situations in the network dynamically. The sender can now retransmit the missing packets before the timer expires. So this behavior, we are calling it a fast retransmit. So it is an early enhancement for preventing slow start to trigger on losses not caused by the congestion. See, we have already discussed it, right? There might be lot of reasons behind the missing packets. So TCP will consider the reason is only because of the congestion. So in order to avoid that, we are applying this fast retransmit. So the receipt of acknowledgements shows that there is no congestion to justify this slow start. See how interesting it is. So here what we are doing, so if the condition is there really in the network, then how do we get the duplicate acknowledgements? So all packets should be dropped, right? So how can we receive this acknowledgement? So that the thing that we have to understand here is, so we are getting some packets, but then they are delayed. That means there is no congestion in the network. There might be some other reason behind this delayed acknowledgements. So to solve that, we are using this fast retransmit or fast recovery mechanism in TCP, right? So here what we are doing, the sender can continue with the current congestion window. So the sender performs a fast recovery from the packet lost. So therefore packet lost is not due to the congestion. So continue with the current congestion window. Okay. So this is how we are going to handle that situation in the network. So that is all for today, and we have seen the introductory part of this mobile TCP. We have seen like what is the purpose of this TCP, and we have seen like what is the necessity for this mobile TCP and how the TCP is not suitable for this wireless networks. And also we have seen what is slow start algorithm. We have seen fast retransmit and fast recovery. Thank you for listening to the class.